All right, so before we move on, let's study the current, the current schematic of the power supply. Now, so this is an FA1 clone. I thought it was a Negrini, but it's I guess they also sell FA1s. All right, so 220 volt AC external power. That's this guy. Or this guy's the replacement. This is not the original anymore. 12 volts AC out. That brings up 12 volts AC. That's important. It's AC, not DC. Okay, then it goes in here. Now there's only one diode to rectify it, and I believe it's the garden variety 1N4001 1 ampere diode. That's this guy here. This one here. Okay, that's this guy. Okay, then you got the two filter capacitors. 1, 2. Just literally just filter out. Yeah, so look at it. It's a half-wave rectifier. Okay, the only time you get power is on half cycle when this is positive. Remember, this is an AC input and this is positive. You charge up the capacitors and you feed it to the voltage regulator. That's the voltage regulator here. There you go. Okay, then you have those high-speed, high-frequency capacitors for filtering, about 0.1 microfarad. That's, I'm guessing, here. And that's these blue, one of these blue ones. I'm not so sure where the other blue one is connected, but never mind. The gist still here is that once you have all the lights on, of course the lights are not drawing current from this guy. They probably are drawing from the point here to directly with the transistor switches. Okay, it goes down up to 6 volts. That's what I notice. Okay, now you need about 1.5 to 2 volts across here to generate 5 volts on the output. Okay, so anytime it goes below 6 volts, the output here is dodgy. I did check it on the oscilloscope and it still wasn't dodgy. I don't know what exactly is triggering the microcontroller to hang, but nevertheless, it's out of spec. Okay, now what's important to notice here that is that 6 volt DC, well, it goes down, so it does help keep this voltage regulator cooler as opposed to DC. We will talk about that in a while. Okay, so a few things to notice. This thing has no heatsink. Okay, it's also loose. It's not screwed down. Its heatsink is supposed to be the PCB at the back here. You'll find some traces there. Okay, but it's just touching. It's not screwed down. And there is no thermal paste. Okay, so I guess the engineers weren't so concerned about it. The original designer, because it's not going to get very hot anyway, because it's only supplying power to the CPU here. And this one won't draw much. It won't draw. That's probably, I guess, 100 milliamps is already a lot for it. Something like that. Okay. So what are we going to do? So, as I said, you can definitely just buy a power brick like this. That's 12 volts regulated, meaning it's pretty much what you see in the stores right now. I don't think you'll see unregulated power supplies like this anymore. The reason I bought this was that I wanted everything to be as faithful to the original as possible. But, it still didn't work. Putting this on, didn't solve the problem. Exactly what the real problem, the root problem is, I'm not very sure. Okay, most likely this guy is 500 milliamps as well. It's not a 1 amp brick, and so yeah, it's at the cusp of working and not working. Okay, in any case, what are we gonna do? So we still use this, so we don't have to buy another one. Okay, and then so what we will do is, after the transformer, we're gonna put a full wave rectifier. Okay, so we can build that around in this area. Won't be too hard, and it's just one component, and the rest is the same. Okay, but remember, now that you're on a DC, okay, the input voltage here will be fixed, whatever your power supply is giving. So this will be 12 volts. But in this case, it's unregulated. If you, in my case, after I did the first one, I made a rectifier. It was at around 17 volts when there's no load. Okay, when it goes with the load, it goes down to 12 volts. Okay, load meaning when the LEDs are on, it's loaded, it's drawing current. Remember, it's going to draw current from here out. Okay, there should be more wires there. I just did not draw it. Okay, what does that mean? Anyway, if you do decide to power it with a DC power supply, the voltage here will be higher. Okay, it will not average 8 or 9 volts as opposed to this one. Okay, it'll average at around 12 volts. Okay, this will make this, well, not that significantly hotter, but this will get hot. It'll get warm. And it's meant to get warm. That's why you have these tabs and these kinds of power voltage regulators. So what we'll do is we're going to screw this down properly, put thermal paste properly, so that, yeah, this guy doesn't heat up too much. Okay, and yeah, show you, we'll on the next video, we'll do the fix. Thank you.